Hello everyone, I am Sheikh Abwanza Said. Currently, I am pursuing my engineering from Mufafamja College of Engineering and Technology. My majors are Electronics and Communication. First of all, I would like to thank Emertxe for providing such an excellent opportunity for students like us to improve our skills and gain a lot of knowledge. I would like to thank Mr. Mubin sir and Balasubramanian sir for providing an excellent opportunity, and I would also like to thank Rajni Shinde ma'am for helping us a lot. She was an excellent tutor and helped and guided us throughout the project. So let us start with the presentation. Our project was Car Black Box. I am also presenting this on behalf of my friends Sheikh Amanullah Sharif and Muhammad Ibrahim. So the contents of this presentation are topics learned during this internship, what is Car Black Box, requirements of this project, microcontroller and microprocessor, Pixim Lab, CLCD, Matrix Keypad, ISR, which is Interrupt Service Routine, timers, and the project implementation. So the topics learned during this internship were: we were introduced to C language, arrays and pointers, functional strings, storage classes, conditional loops and operations. We were also introduced to embedded systems and microcontrollers. We were taught about MPLAB XIDE, which is an integrated development environment. We were also taught about compiler X8 compiler and the simulator Pixim Lab. We were also introduced to various peripherals of PIC16F877A microcontroller. And lastly, we were also exposed to a lot of quizzes and workshops. So the requirements of this project were the MPLAB XIDE, which is an integrated development environment, and the compiler used was XC8. PIC16F877A was the microcontroller which was used. Pixim Lab was a simulator. We also used CCLDs, MKB, timers, and tactile switches. So what is car black box? We all know that black box is an electronic device which is used to record events. Similarly, a car black box is either physically installed in a car or downloaded as a smartphone app. It links to a GPS device that measures and records vehicle speed, location, distance traveled, driving frequency, and time of the day the car is in motion. It is also known as event data recorder or accident data recorder. Let us see the advantages and disadvantages of this car black box. Let us first see the advantages. It is a reliable device. It is easy to extract the data, easy to analyze the recorded data. It will not affect the privacy of the driver. It will help. It is helpful for the car manufacturers to improve the car design. It, it helps the investigation team. It helps the insurance companies if it is connected to the GPS system. This module alerts the accident to the present mobile numbers stored in it. The alert message includes the location in latitude and longitude. And the disadvantages of this car black box are, as the black box mainly consists of an electronic circuit, there are chances of damage. So if the box is damaged, there would not be the signal would not be transmitted, or the message that is to be transmitted will not be sent. So let us start with the microcontroller and microprocessor. Microprocessor consists of only a central processing unit, whereas microcontroller contains a CPU, memory, and I/O all integrated into one chip. Microprocessors is used in personal computers, whereas microcontroller is used in embedded RAM system. A microprocessor uses an external bus to interface to RAM, ROM, or other peripherals. On the other hand, microcontroller uses an internal controlling bus. Microprocessors are based on the von Neumann model, and whereas microcontrollers are based on Harvard architecture. Microprocessor is complicated and expensive, with a large number of instructions to process, but a microcontroller is inexpensive and straightforward with fewer instructions to process. This is the architecture of the microcontroller PIC16F877A which was used in this project. CLCD. So there is a typo. CLCD is character liquid crystal display. In Pixim Lab, there are two types of displays. One is 16:2 display and 16:4 display. It displays the ASCII characters ASCII characters and some special characters. It is most commonly used display. Two types of communication modes. One is 4-bit mode and the other one is 8-bit mode. MKP, which is matrix keypad. This is a keypad in which the number of tactile switches is connected in the row and the column concept. This is used when more users inputs are required and still want to save some controller input-output lines. These keypad are most commonly used in telephones, calculators, digital lockers. ISR, which is interrupt service routine. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enable, places the address from the program counter on the stack. Interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. It goes back to the processing where it was got interrupted after servicing the request. Polling. Polling is a process where the computer or controlling device waits for an external device to check the readiness or state, often with low-level hardware. Timers. Timer is an important application in any embedded system which is a default peripheral that maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time, generating delays, etc. Timer counter is a software designed to count the time intervals between events. The resolution is also called as register width. Tick is referred to as change from one number to another number. It may be up-counted or down-counted. Quantum, which depends on the system clock setting, is a measure of time that is responsible for the tick. Scaling may be pre-scalar or post-scalar. So this is the interface which was provided by the Pixim lab. In this, we have a CLCD display, the SSDs, that is 7-segment displays, MKPs, switches, LEDs, potentiometers, and the most important component, which is our microcontroller, and various other components like buzzers, ADCs, relays, etc. So first of all, uh, we should select the board, which is PicGenius for this project. After this, we should select the microcontroller which is used, that is PIC16 F877A, to implement this project. Now let us get into the project implementation. So after implementation, the dashboard that would appear would be similar to this. It would display the time, event, and the speed. The time is displayed here, event is displayed as on, speed is displayed as 10. This is the login screen. It would ask for a password to login, and if the password is wrong, the user would be blocked for uh, for a time which is given earlier. After entering the correct password, the main menu will be displayed on the CLCD. The main menu consists of view log, clear log, and change password options. So view log displays all the events which were recorded. Clear log helps us in clearing all the events, and the change password option helps us in changing the password, or that is to help us for resetting the password. Events. So there were about 6 to 8 events which were used in this project. So it is displayed here under the E. Presently it is displayed as on, and there were various events like G1, which is gear 1. So in the car we have a lot of gears like reverse gear, neutral gear, gear 1, gear 2, gear 3, and gear 4, and some also have gear 5. But here we implemented up till gear 4 only. And we also included an event called collision to record accidents or collisions between two vehicles or any component with the vehicle. So the list of events is the list of event is listed here. GN is gear neutral, GR is gear reverse, G1 is gear 1, 2 is G2 is gear 2, G3 is gear 3, G4 is gear 4, and C is collision. Thank you. Now let us see the simulation using the Fixing Lab simulator. This is the complete block diagram or the presentation of our microcontroller chip. This is the CLCD display which displays the events. These are all the switches, that is RB0, RB1, RB2, RB3, RB4 and RB5. So we can click all these uh, buttons to record the events and change all events and navigate throughout the options. So if we click RB1, so the events are changing as we can see on the display. It is changing from G1 to G2 to G3, G4, etc. And if we want to down count or do the same, we can click the other button. And we also have other buttons like RB3, RB4, where RB3 and RB4 can be used to get into the login menu as shown on the display. It is asking us for the password, so we can enter the password to get into the main menu. We can click on RB3 or else we can click on RB4 for getting into the login menu. After that we can enter the password, which is a combination of those two buttons RB3 and RB4. After entering we can see the view log and the clear log, and the third option is password reset option. So we can use these buttons, that is RB3, RB4 and RB5, for getting into or navigating throughout these options. So as we have already seen that there are three options, that is view log, clear log and also the password reset option. So if we click on RB3 or RB4, we can see the we can navigate through these buttons and change our options. So if we want to change our password, we can click on RB5 and we can change our password by entering the new password. And after that we can also re-enter the new password so as to change our password. After this, that is displayed as password change successful. Later we will be redirected to the main menu where we can see the view log. After we can click to RB5 so that we can enter the view log, and we can see the various events which are displayed on the screen, and we can navigate throughout the events by clicking on RB3 and RB4 switches. And as shown on the CLCD display, the events are changing when we are clicking on the RB3 and RB4 switches. The serial number is displayed under the hash. We can close this by we can see that the events are displayed under the serial number hash. Thank you.